Hey everyone, and welcome. Today, we're diving deep into a molecule I bet you've heard of, serotonin. You know, it's always called the happiness chemical, but as we're about to find out, that little nickname barely, and I mean barely, scratches the surface of what this incredible thing really does. I mean, seriously, what if its role in our bodies was way more complex, way more influential, and even a bit more mysterious than we ever thought? That's the big question we're tackling today. And trust me, the answers might just change how you think about everything, the connection between your brain, your body, and your mood. See, the thing is, serotonin isn't just about happiness. It's what we call a master modulator. So think of it less like a simple on-off switch for feeling good and more like a master control panel, fine-tuning pretty much all the signals in your entire nervous system. It's one of the most powerful chemical messengers we've got. All right, so let's dive into our first section and really look at just how widespread serotonin's influence is. And we're going to kick things off with a number that I think might just blow your mind. Okay, get this. 95%. That is the amount of your body's total serotonin that's found in your gastrointestinal tract. Yeah, you heard that right. Your gut, not your brain. Which, leaves this tiny little sliver, just 5%, up in the central nervous system where all that mood stuff we hear about actually happens. So, what's going on here? Are these two big pools of serotonin connected? Well, the answer is nope, not at all. There's something called the blood-brain barrier that serotonin can't cross. So this means the serotonin in your gut and the serotonin in your brain are two totally separate, independent systems. They're made and used in their own local neighborhood, so to speak. The gut serotonin is busy regulating digestion, while that brain serotonin gets to work on a whole different to-do list. And wow, what a list it is. That tiny 5% in the brain is an absolute master of multitasking. It's modulating everything from your mood and your ability to think to how you learn and remember things, how you process rewards, your sleep cycles, your appetite, and even how you experience anxiety. It's seriously the brain's ultimate jack of all trades. So how on earth does one tiny molecule pull all of this off? To figure that out, let's zoom in a bit. In our next section, we're going to look at how serotonin sends its messages at the most basic level. How does this chemical conversation actually work? Well, believe it or not, it all starts with a recipe. Your body takes an ingredient you get from your food, this essential amino acid called L-tryptophan, and then, through a two-step process using a couple of helper enzymes, it cooks it up into 5-HT. And 5-HT is just the scientific name for good old serotonin. Okay, let's take a second with this diagram, because this is where the magic happens. First, look at that top neuron. That's the one sending the message. Serotonin gets packed into those little bubbles, called vesicles. When it's time to talk, it releases the serotonin into that gap, the synapse. Now follow those little dots as they float across to the neuron on the bottom. You see how they dock into those little landing spots? Those are the receptors. That's the message being delivered. And then finally, see that thing labeled SERT? That's the serotonin transporter. It works like a tiny vacuum cleaner, sucking up the leftover serotonin to be used again. It's a perfect little system of sending, receiving, and recycling. And that word we just used, synapse, it's absolutely key. It's just this incredibly tiny gap between two brain cells. And to get a message across that gap, a chemical like serotonin has to make a leap. It's like a chemical leap of faith that happens trillions of times every single second inside your brain. All right, so let's zoom out again. We've seen what happens at one tiny gap between two cells. But how do these little chemical leaps create a massive brain-wide system? How do we get from a single synapse to a serotonin superhighway that wires the entire brain? Well, it all starts in one tiny command center. Pretty much all of the brain's serotonin is made in two little clusters of neurons tucked away deep in the brainstem. They're called the dorsal and median raphe nuclei. Just think of this place as the central station for the entire serotonin system. And from that one central spot, you can see these projections, these long wires called axons, just spreading out like an incredible superhighway. They reach almost every single part of the brain. The cortex, where you do your thinking, the amygdala for your emotions, the hippocampus for memory. This is it. This is how that little 5% of serotonin can have such a massive brain-wide impact. Now, this amazing superhighway is what allows serotonin to tune the entire brain. But it also means that if you get a problem at that central hub, or maybe a traffic jam somewhere along the routes, the consequences can be just as widespread. Which, of course, brings us to the really important question. What happens when that signal fails? And the research on this is crystal clear. A disturbance anywhere in this system, whether it's in making serotonin, sending the signal, or recycling it, doesn't just cause a small glitch. It can play a central role in a whole host of serious psychiatric conditions. And just look at the range of conditions here. It's huge. We're not just talking about depression and anxiety, which most people already link to serotonin. We're also looking at connections to OCD, schizophrenia, even ADHD and eating disorders. It really just hammers home how fundamental this one system is for our mental health. But here's where it gets really interesting. It's not as simple as, oh, you just have low serotonin. Check out this table. It shows that different disorders are linked to problems with different combinations of serotonin receptors. So if you notice, depression and anxiety share a lot of the same receptor subtypes, but OCD involves a slightly different mix. This kind of specificity is a massive clue for scientists. And that right there, that specificity, it brings us to our final and honestly most important point, the mind-boggling complexity of this whole system and why, when it comes to things like treatment, one size definitely does not fit all. So just how complex are we talking? Well, there isn't just one type of serotonin receptor, one landing pad. No, there are at least 7 different families of them, and many of those families have their own subtypes. And each one is in a different part of the brain and does a slightly different job when serotonin docks with it. I love this quote from the source material because it says it all perfectly. Serotonin can have frequently opposing mechanisms. What does that mean? It means depending on which of those many, many receptors it clicks into and where that's happening in the brain, serotonin could be hitting the gas on one brain circuit while slamming on the brakes on another one right next door. So what does this all mean? Well, this crazy complexity is both a massive challenge and an incredible opportunity. It's a challenge because a single drug that messes with the whole system can have all sorts of unwanted side effects. But it's an amazing opportunity because the more we understand, the more we can create super specific, targeted therapies. Imagine designing a drug that only hits the one receptor subtype involved in anxiety without messing with mood or sleep. That's the future. And it just leaves you with this final, kind of mind-bending thought. Serotonin is so much more than the happiness chemical. It's a master key that unlocks countless doors all across the brain. And it really makes you wonder, what other master keys are still out there, just waiting for us to figure them out?